Okay, let's start recording. This is Elements of Nuclear Physics. We'll cover some basics, like stable radioactive elements, basics of nuclear physics, and then we'll do the fission chain reaction, the spallation nuclear reaction, and the fusion thermonuclear reaction. Okay. So this is related to the atomic bomb, and this is related to the hydrogen bomb. But they're used to produce neutrons and so on. So stable radioactive elements. So we see the number of protons, number of neutrons, all of the nuclei that exist, and their isotopes. So we see that the stable elements are higher than n equals z, so they have excess neutrons there. So this is where radioisotopes are produced in reactors, and this is where radioisotopes are produced in accelerators. These are beta emitters, and these are positron emitters. And we'll see about beta. Those are electron, and positrons are like electrons but positive charge. A neutron activation produces gamma emitters. So we know that the neutron decays into a proton, a beta, which is an electron, and a neutrino, with a half-life of about 20 minutes. So basics of nuclear physics, we see the nucleus here, about 10 to the minus 13 centimeters. That's called the Fermi. And we see the atom here, 10 to the minus 8 centimeters. That's what we call an action. So we see the electrons in electron shells. When they decay, there is either light or X-ray emitted, while gamma rays are emitted from the nucleus that contains protons and neutrons. Okay, so hydrogen isotope has one proton and one electron. Helium, there it is, has two protons and two neutrons. Those are the nuclei. Helium-4, 2. Okay? 4 nucleons, of which 2 protons. So there's the neutron, doesn't have charge. There's deuterium, which forms deuterium without the electron, which has proton and a neutron. There's a triton, which is ionized tritium, has 2 neutrons and a proton. Remember that this is the terminology we're using: atomic mass and atomic number. This is number of protons, this is total number of nucleons, protons plus neutrons. Remember that the proton is much heavier than the electron. Okay, so the fission chain reaction, a neutron is absorbed in, for example, uranium-235, which is uranium is the heaviest element, stable element. So it splits into 2 fission fragments and gives off 2 to 3 fission neutrons that slow down. Okay? And then they produce fission again and again and again. And neutrons are slowed down to be used for neutron scattering, for example. Okay? If you were to look into a reactor, nuclear reactor, you would see a pool for water for slowing down neutrons and to remove heat, and you will see blue color. This is called Cherenkov radiation. This nuclear reaction produces a lot of electrons, betas, at very, very high speed, relativistic speeds. So when they're slowed down in water, they produce the blue glow called the Cherenkov radiation. Okay, so this is one way of producing neutrons, fission chain reaction. Another way is called the spallation nuclear reaction. In this case, when a proton is absorbed into a high Z material like tungsten or natural uranium, there are 10 to 30 neutrons that are emitted. When they're slowed down, they can be used for neutron scattering as well. Okay. The third nuclear reaction we'll cover is the fusion thermonuclear reaction. If you have two light elements like deuterium, one proton, one neutron, and tritium, so one proton and two neutrons, they can fuse together to produce helium and an extra neutron and produce helium and a neutron, 14 MeV energy. Okay, lots of energy. This nuclear reaction occurs in the sun, and this helium-4 is called an alpha particle. All stars produce energy through this fusion thermonuclear reaction. Okay, that's pretty good. That's